that blue activity yesterday. If you were gone yesterday, the gold sheet and the blue activity are in the green folder over there. But you guys did a really nice job like deriving the law of sines from creating two right triangles in a triangle ABC that is not right. And you should have come up with something that looks like this. Now your formula for law of sines could have been like the reciprocal version of this. So you can say sine A over A equals sine B over B equals sine C over C. And however you choose to do it on quizzes and tests is A-okay with me. It'll work out the same way. Just to clarify, what the law of sines says, okay, and I'm going to put a little star here, can be used for any triangle. Does not have to be right. Okay, so that's where we're going in chapter 6. Can you solve triangles that aren't right triangles? So like in that ACT test prep, that was a right triangle, so we could use Pythagorean and SOHCAHTOA. But if it's not right, you can't. Well, now that you've derived the law of sines, or you've created the law of sines, you can use this for non-right triangles. So obtuse triangles, it works. Acute triangles, it works. It even works for right triangles. But it says the ratio, so the fraction or the comparison of a side length to the sine of the angle opposite that side is the same for all pairs of corresponding angles and sides in the triangle. It doesn't mean that the sides are all equal, like an equilateral triangle. It's just saying that the ratio or the comparison to the sine of the angle will remain the same. Okay. And you don't necessarily have to draw this triangle, but I just want to point out to you that when we're drawing triangles in chapter 6, think back to geometry, I usually just label my vertices A, B, and C, and then you know which sides are which because side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Okay, so that will always be true. Here's an example of using the law of sines. Just as a reminder, we're coming from different places. If you're an Honors Algebra 2 student, you learned the law of sines, you used the law of sines, but you did not cover the ambiguous case, which we're going to do on Monday. So that'll be new to you. If you are an Algebra 3 student, you should have done law of sines and the ambiguous case last year, so you've seen both today and tomorrow. And if you're coming from Algebra 2, you did not see the law of sines. This may be brand new to you. So when you're working on homework, if there are any gaps to fill in, make sure that you ask about those things. This is how I think the textbook presents the problems, gives you like some angles or side lengths. Some of you may prefer visually to draw out a triangle ABC. I personally like to draw the triangle because I'm going to show you at the end how you can kind of check to verify that your answers make sense. And then I just label the parts. So 118, 36, and 10. All right, help me out. What can we find if we're trying to solve the triangle, find all the missing pieces? A is super easy, right? If you know two angles of a triangle, you automatically know the third angle. So for the sake of notes, I'll write it down. 180 minus 118 minus 36. Somebody give me that calculation. Okay. So A is 26. I can fill that in over here. Okay. And then I'm going to talk about setting up the law of sines because remember, we're 3 different groups of people in here, so we might be coming from a different place. Okay. If you're setting up the law of sines, there should always be a pair of corresponding parts, an angle and the side opposite the angle that you know both numbers. In this particular triangle, the only side we know right now is 10, and that's side C. So I have to use in my law of sines the ratio of C over sine C. So I'm going to set that up. 10 over sine 36 degrees. Okay. So I know what that value is. I'm not going to evaluate it right now and round it. I'm going to leave it in exact form. And I know that for the other sides and angles, they share that same ratio of side length over sine of the angle. You can choose at this point if you want to solve for side B or side A. Which one do you guys want to solve for first? A. Okay. So I'm going to set up A over the sine of 26. And it does not matter which one you choose to solve for. So if you're solving for B, that's fine. Okay, again, not everybody has seen this before, so let's just clarify. I only need to use 2 of them. I don't need to use all 3 because I want to create an equation that I can then solve for A. I don't want to put in the B because then I'll have 2 unknowns. How would you solve an equation that looks like this? Fraction equals a fraction. Cross multiply. Excellent. So if I cross multiply, I'll get A times sine 36 equals 10 times sine 26. And I don't even calculate yet because I don't want to round, right? I want to solve for A. It's being multiplied by the value of whatever sine 36 is, so I have to divide. This is probably the one time I'm going to show all this work. Normally I don't write all the steps down. Okay. So I divide by the sine of 36. On this side that cancels out, so I just have A equals. And you guys in your calculator are going to do for me 10 sine 26 divided by sine 36. And if your calculator brings up that parenthesis for a sign, make sure that you close it before you divide. What would also be really important about your calculator right now? It must be in degree mode, so you might want to check your mode. Okay, make sure that you're in degree mode. Let's see, Dylan is getting 7.46. Zach seconds that, so make sure you can get 7.46 for A. Let me know if you don't, and I'll come check your calculator. Now, we found A. We know C. We have to still find B. Since this is not a right triangle, there's no 90-degree angle. You cannot use Pythagorean theorem. You're going to use another law of sines. Okay, so I could set up my law of sines. I usually just use the same ratio that I knew originally, so I would use like 10 over sine 36 equals B over sine 118. Okay, so I use the other ratio that I didn't the first time around. And then I think a lot of you, like I know some of you, like on your homework tonight, you could probably calculate without writing it down. But on the quiz or the test, please write down what you're doing in your calculator. Otherwise, I can't give you partial credit. But a lot of us are probably okay with cross multiplication, that we don't have to do like all the individual steps. We can just say like in my calculator, I'm typing in 10 sine 118, and I'm going to end up dividing it by this sine 36. And then we can say what B is equal to. Anybody got B for us? 15.02. Okay. Okay, now the last thing that I'm going to do with this is talk about something that will be really helpful going forward with the ambiguous case on Monday and even the law of cosines on Tuesday. So there are some like weird things that can happen when solving triangles that you have to consider, and I'll point those out when we do them. But I like this visual of my triangle where I fill in all my angles and all my side lengths, because at the end, you know your answer is reasonable, your answer makes sense, if in the triangle, the longest side is opposite the largest angle. The smallest side is opposite the smallest angle, and medium to medium. So when I look at my triangle, angle B is the biggest, and side B is the largest side length. Angle A is the smallest, side A is the smallest side. So barring that I've made no like minor calculation error, I'm feeling like really good about this. Okay. There is something you have to be really careful of in law of cosines, an ambiguous case, because sometimes you might actually find a triangle that doesn't actually work. When you would like label everything or look at them side to side, they would mismatch. So that means, oh, I should have thought about something really, really like detailed. Okay, so that's a nice way to check your answers before you turn in quizzes and tests. All right, any questions on the law of sines for me? It's going to be easy tonight, don't worry. Okay, last thing we want to talk about before you get started on your homework is the area of a triangle. Okay, I heard some mumblings already. What is the area of a triangle that you know? Base times height divided by 2, or some people say 1/2 times base times height. What's really important when you're choosing your base and your height of that triangle that you're calculating the area for? What has to be true about those two things? Base and height. They have to make a right angle, right? We talked about that with the altitude yesterday on the blue packet, that an altitude is a height, and a height is only a true height if it's forming a 90-degree angle. So in the triangle, if it's not a right triangle to begin with, you really need to know this height value, and then you have some base B. Okay, so what you're going to see in this chapter is maybe I'll give you a triangle, and I'll give you, like I've got the triangle labeled up there, ABC, sides ABC as well. I'm not going to give you the height in the middle of the triangle. I'm not going to give you the altitude. I'm just going to give you some side lengths or some angles and ask you to calculate the area. So there are actually formulas that you can use for this. Okay, we're going to generate one version of the formula. So it's kind of similar to what you did with the law of sines. Let's draw in an altitude. Okay, so I'm going to start from vertex B. I'm going to draw in the altitude, okay, which forms a 90-degree angle, and that's going to be the height of this triangle. So I could do like 1/2 times base times height right now, right? Okay. But let's say we didn't know what that h was, so we're going to do like we did yesterday, and we're going to create a trig expression with the right triangles that includes h. So I'm going to look as if I was over here at angle C. Okay, so I'm looking at this right triangle right here. Okay, in that particular right triangle, I don't know this actual small side because it's some portion of B, but I don't know how much. It's not necessarily exactly half. But I do know H and A, which in relation to C are the opposite and hypotenuse. So we can write the equation over here on this side. The sine of C is equal to H over A. And you could potentially solve for H by multiplying both sides by A. So the height, if you're looking from sine C, is A times sine C. Okay, now if you were looking from angle A, it would be C times sine A. And if we needed like angle B, we'd have to draw in the other altitude, right? And we could do a sine value with B. But we could just make a substitution for the formula that you gave me up here. The area equals 1/2 times, okay, and now I'm not focused just on the green triangle, I'm focused on this whole big triangle. Okay, where my altitude met, that side was my base, which is actually side B, so it would be 1/2 times the base, which is side B. And then I would multiply it by the height, but we're saying that the height is A sine C. So if you know two sides, B and C, and angle A, you can use this formula. This is going to look like side angle side. So we're going to see these like notations that you might recall from congruence postulates in geometry. But if you were in Algebra 3 or Algebra 2, you probably talked about these as well when you did law of sines and law of cosines. It would mean I know two sides and I know the angle right in between them. So that's called the included angle. Okay, so if you know two sides and an included angle, you can use this formula. Probably most mathematicians would write this so that it was A times B, because they like to write things in alphabetical order, but it doesn't really matter what order you multiply, right? Okay. There are three other versions of this. Okay. If you're looking from angle A, remember it would be C times sine, so it would be B times C times sine A. And then if we drew in the altitude so that we could look at it from angle B, the other version would be 1/2 times A times C times sine B. I'm not saying memorize all three equations. Okay, I would not do that. What you need to know is if you have side angle side, it's 1/2 times the two sides you know times the sine of the included angle. So I'll show you an example of what that looks like here in just a moment. We're going to find the area of this triangle. And we'll see another area formula where I'm not giving you side angle side this chapter. So it'll be a different version. If I quick sketch out triangle ABC, I know angle A is 65, side B is 15, and side C is 22. So this is what I'm talking about right here. This looks like side angle side. Two sides and the angle right in between them. Certainly you could draw in an altitude and do a right triangle trick to find the height, but we can also just use our formula that we've derived, 1/2 times the two sides, 22 times 15, times the sine of the included angle. Plug it in. Got an answer. So if you have side angle side, 1/2 times the two sides times the sine of the included angle. That will give you the height, the altitude. Okay, I think that's in the 100s. Not sure of the number. 149.54. And because this is an area, I'm going to give it a label. Units squared. Okay, remember, even if you forget the formula on a quiz or a test, you could still answer this question by drawing in the altitude and doing right triangle trick. So don't give up. You could still figure it out. Okay, the rest of the time is going to be yours to work on your homework assignment. It's a nice chunk of time. These problems don't take very long. Okay, there's a few where you're solving. And then there are some where you're doing just areas, so those area problems will go by very quickly. Your homework is on page 408, and I've got the first three on the board, so everybody can get started right away.